and tangent lines. Now there's going to be a little bit more algebra in here, so we're gonna just as a review, and this is what you did on your homework, talked about the power rule, which works with power functions, and the power rule states that the derivative of a function that is written as x to the n is equal to n, you bring that power down, times x minus x to the n minus 1. So that's the power rule, and that is still the power only rule that you're going to use today. So the good news and the important news for today is that you are only utilizing one derivative rule, and that's the power rule. You are not doing anything else. You're not, if I say if you have to take a derivative, the good news is that this is the only rule that you have to use. Now, you also have to differentiate between derivatives and algebra. So that's one of the hardest things, and it really takes practice. Okay, it's like learning a new language. It's just getting comfortable with the differences and when you're doing one versus when you're doing another. One is a derivative, which means you're finding slope. And the other is algebra, which means you're manipulating. You still have the same thing that you have. And it's also important that the derivative itself is also a function. So you have the function f of x is the function, and f prime of x is the derivative function. So they're both functions, and that's also important to realize that the derivative itself is a function. F prime of a is the derivative slope at a point. All very important pieces. Now, when you are finding the derivative, all right, there's application. So really, I guess today is not as we're talking about the derivative. We're really talking about applications. So when we talked, and you're going to have questions again tonight on the tangent line, but the tangent line questions are going to be much easier to do now. So if you're finding, the equation of the line tangent, and we could have done normal as well. We'll say we're just tangent right now, to y equals f of x at x equals a, and you're going to be given the function f of x. It's a very important formula. Y minus f of a, not f of x, equals f prime of a times x minus a. And as you can see here, you have f prime of a, but now you can and you should use derivative rules from now on. And that means today, and the only derivative rules that you know is the power rule. Now, technically, there were a few other rules that we threw in there. We talked about the constant rule, which is a power rule, I guess. We talked about the constant multiple, so if you have something multiplied by it. We talked about the sum and difference, which just means you just take the derivative of each little piece. So for example, f of x equals x squared plus 2 over x. Find the equation of the line tangent to f of x at x equals, let's go with 2. No, I want a fraction in there. No, that still will give a fraction. At x equals 2. A lot of 2's flying around. Yeah, that looks good. All right. Where do I start?
For the x squared.
Before there.
Before that.
What is the problem asking me to do? So what is the problem asking me to do, and where do I start from there? Well, where's the recommended start? I guess because there's a lot of different places you could start. What are we trying to find? What is the first premise of this question? What are we trying to find? It's written right there, the problem.
Find the equation of the line tangent.
Okay, good. And it's at x equals 2. So, y minus f of 2 equals f prime of 2 times x minus 2. So we're going to write the equation of the tangent line, the general formula with the tangent line, at the indicated point. That's where we always want to start. All right. Could you get away with not doing this? Yeah, technically you could find, and I think this is what Darwin was going for, was trying to find f of 2 or in trying to find f prime of 2. I mean, technically that's right. It's not my recommendation in terms of getting into, you want to try to build some type of algorithm into your processing mind. So I like to write down the formula first. All right, let's just make sure, like, oh, okay, now I need to find f of 2. And I need to find f prime of 2. Everything else stays in the problem. All right, so what am I going to try to find first? What do you want to find first?
F of 2.
Okay, so f of 2 equals 2 squared plus 2 over 2, which is 5. Good. What am I going to find next?
F prime of 2.
Correct, but here comes the big one. To find f prime of 2, what do I have to find? What do I find next?
Derivative.
The derivative. Good. I have to find f prime of x. And this is what happens in calculus a lot. But to find f prime of x, what do I have to do first? There's a lot of like, oh, I have to do this. Oh, but before I can do this, I have to do this. Ah, but before I have to do this, I have to do this. So there's a lot of that happens along with calculus because it just comes with putting things in the right order and putting things in the right forms so that we can work with it. So before even I can find f prime of x, so I want to find f prime of 2, but I got to find f prime of x. But in order to do that, I need to do something with f of x. Which is?
The power rule?
That power rule is a derivative. What do I have to do to f of x? So the power rule is what I'm going to have to do to find f prime of x. That's what I'm going to have to do to find f prime. But what do I have to do to f of x? And it's along the lines of what Ariana was saying. And this is going to be the tail. This is probably the tail of when you do your own homework. This is the same tail that you have to do over and over and over with these type of problems.
Write the equation down?
Well, rewrite the equation in calculus friendly. So I usually refer to it in my lessons as, all right, we got to make this function calculus friendly. Right now, it's not calculus friendly. We cannot take the derivative of the function the way it's written. So f of x is x squared plus 2x to the negative 1. Unless you're doing that step, I mean, is it possible that you can? Yeah, I can do the derivative of this at the top of my head, but that's only because I've been doing this for like 20 years. All right, and I feel comfortable. I can take the derivative of 2 over x, no problem. And hopefully by the end of this course, you'll be able to do that as well. You'll see the numbers that happen. But in reality is, even then, probably likely to make a mistake. So let's write it down. Let's write this down as f of x equals x squared plus 2x and negative 1. And now we can do what? Now we can apply the... There's no h's. No h's at all. You shouldn't be thinking about h's anymore. That's what I was trying to note here. H's are unit 1. Good news and bad news. Good news, you don't have to worry about them right now. Bad news, you spend all that time learning them, but it's still applicable. There's still going to be parts when we're going to utilize the limits and why those means what they do. And it's a big part of the AP exam. So what are we going to do? Once again, the answer is still up here. What are we going to do? Do the power rule. 2x minus 2x to the negative 2. And what other thing before I plug in, because I know that's probably your next thing, I'm going to rewrite this as 2x minus 2 over x squared. Now, why did I rewrite it as 2x minus 2 over x squared?
So you can put it as positive for the x squared?
Yeah, so and the reason if I want to put it as positive, and the reason is because I have to plug in. It's easier to evaluate. It's easier. This is to evaluate. Algebra friendly. So now I can just plug in 2. I get 2 times 2 minus 2 over 2 squared, which gives me 4 minus 2 fourths, which is 4 minus 1/2, which is 7 halves. And that gives me my equation of my tangent line now. Y minus 5 equals 7 halves times x minus 2. So you're doing the same thing that we did in our last unit. But now these problems are easier. This is when I had given you those 4 problems on the homework when you had to do it in paper and you had to take the derivative. Because in finding the derivative, you're now using the power rule rather than having to do the limit as h approaches 0, which should feel a lot more happier for. And it also allows us to do functions that we weren't worrying about when we were doing definition of the derivative. I try to keep it nice and simple, but now I can make the problems and the functions a little bit trickier, and I can combine a little bit of functions because once you know the process of the definition of the derivative, or sorry, the power rule, these become rather not as difficult as before. Now, there's 2 types of problems. So the first thing you want to do is to find f prime of a. Second type of thing in terms of calculus is is tangent lines. And the next thing we're going to do is solve f prime of x equals some constant. So this is what we're going to be doing right now. So this is our current part. All right, so we know how to plug the derivative in, and now we know how to utilize it to make a tangent line. The tangent line part, and I just want to reiterate, the tangent line part is review. All right, the y minus f of a equals f prime of a parentheses x minus a. That's review. We've already done that. The only thing that we did is we took yesterday's lesson, or sorry, Wednesday's, and we plugged it into that old lesson. So really, so far, I have not taught you anything new. So far in these notes, I have not taught you anything new. All I did was I combined 2 prior lessons. That's all I've done. I combined 2 prior lessons. So let's teach you something new. Solve f prime of x equals k. Now, what I mean by that is you're going to solve for the x value when the function has a specified slope. Okay? It's algebra. So for those of you missing the algebra solving type of problems, this is a common practice. This is a common practice problem where we set up an algebra problem using calculus, and then solve using algebra. This is something we're going to do over and over and over within this course throughout the course of the year. You're going to use calculus to set up something. You're going to set up the problem, and then you're going to do the problem, which is mainly algebra. So it's like 2 parts to it. There's a calculus aspect to it, and then there's an algebra aspect to it. Sounds a lot more complicated than it actually is. Example. F of x equals 3x squared minus 4x. Find when f prime of x equals 10. Now, I can work, this problem might be worded differently at times. It might be worded like I put it up in the top problem. Find when the slope, it might say, you know, this part right here, when it'll say when the slope is 10, you know, it might be worded like that. And when it says the slope is 10, it's your job to realize that, oh, f prime of x equals 10. So when I say the slope is 10, so right now I literally said when f prime of x is 10. In other problems, it's going to say when the slope is 10, and then you got to go, okay, so that's saying f prime, the derivative equals 10. All right, and now all you got to do is find f prime of x, replace it. It's a lot of like replacing and then solving. So what's f prime of x? What's f prime of x? Don't overthink it. It should be very straightforward. I hope. I hope it's just that you're not want to share. What is it? No. What is f prime of x? What's the function? We're going to find when f prime of x equals 10. But now we got to find what is f prime of x before we do that.
Is it like 6x minus 4?
That's it. 6x minus 4. And now 6x minus 4 equals 10. We found the derivative, and the derivative is equal to 10. We're finding when the derivative equals to 10, but when we find the derivative is 6x minus 4. That's the power rule. And we set that equal to 10. And finally, we just do some good old algebra. Plus 4, 6x equals 14, divide by 6. x equals 7/3. Done. Remember, power rule, derivative. When I say find a derivative, basically from now on, you're using derivative rules. Now, the f prime of x equals 10 is there because that's the algebra equation I'm going to have to solve. Finally, higher order derivatives. Sounds like a big word. Don't worry about it. It just means find, you're going to find derivatives of derivatives. Okay? So higher order derivatives, all it means is that you're going to keep finding, you're going to find it, you find a derivative, then you're going to take the derivative of that derivative. And then you might take the derivative of that derivative. So you're just going to do the process multiple times. So when I say f prime of x, this is also known as the first derivative. Okay, so f prime of x, we can also state that in calculus in terms of vocabulary, the first derivative. So I can say find the first derivative. Same thing as the derivative. The derivative is the first derivative. F double prime of x is the second derivative. It is the derivative of f prime of x, or it is the derivative of the derivative. And I can ask you for the third derivative. I can ask you for the, once you get to 4, we do it like this. We do a little parentheses because once we get to 3 tick marks for 3 primes, it gets getting a little lost in there. So we start writing the numbers and we put the number in parentheses, which signifies derivatives. And so we will say like to the n. And that's the nth derivative. All you got to do is take the derivative and continue the process. So you're just continuing the process of the derivative. And the rule, remember, when you hear derivative, you're just thinking derivative rules. No more definition of derivative for today's work in the near future, really. We're not going to use the limit as h approaches 0 work. We're just taking derivative rules, and the only rule that you know is the power rule. Example, f of x equals 3x to the 5th minus the square root of x to the 3rd. Find the fourth derivative of x. To find the fourth derivative, I have to first find the what? What do you think I have to find? In order to find the fourth derivative, what am I going to have to find first? Or what do I have to find before that?
First one?
The first derivative, yeah. I have to find the third derivative, I have to find the second derivative, I have to find the first derivative. So I have to find the first, second, third, and then the fourth. So I can't just jump all the way to the fourth derivative. There's no magical rule. You just got to do out the work. So the first thing we got to do is find the first derivative. But before, and like I said, before we find the first derivative, what do I have to do?
Find f of x.
Rewrite. Yeah, simplify, rewrite, algebra friendly, f of x. Good. So that gives me 3x to the 5th minus
X 3/2.
X to the 3/2. Okay. So f prime of x equals
to 15, x to the 4th,
keep going.
minus 3 over 2, x, 1/2.
Perfect. Now we move to the second derivative. Just taking the derivative.
60x to the 3rd,
Oh, don't stop now.
minus 3 divided by 4x,
Oh, no, not 4, not 4x. 3 over 4, 3/4.
3/4, and then x. Give me
1 minus 2.
like negative 1/2.
Let's find a third derivative.
X squared.
We keep stopping. That's for
Plus 3 over 8 x.
negative 1 minus 2. Just subtract the denominator from the numerator.
Negative 3 over 2.
And finally, we can finally answer our question. The fourth derivative of x.
$360x.
Everybody always cuts themselves off after their first piece.
What a fraction. That's the most fraction.
No, it's just a number. Minus.
9 over 16. X. And then maybe like negative 5 over 2.
And that's my answer. And that's my lesson for today.